5.2 video, we're going to be talking about rational functions and their graphs. A rational function looks like this here. It almost looks like the inverse variation equation, which it actually is. Or we can also say that f of x equals 1 over x, and this is the general graph of when the constant a is 1, and it looks like this. Now, what this type of graph is called is a hyperbola. And if you notice in this graph, there is some asymptotes going on, and one of those asymptotes is the vertical line of x equals 0, and also the other asymptote that we have going on is the horizontal line of y equals 0. And as you can tell, this graph in blue cannot go past these asymptotes. And so that's why they look the way they do. Now there's an equation that you're going to need to know for domain and range. And this is the general formula for this. So make sure that you have all of that in there. And then also make sure that you have this part, domain and range. You're going to need this when we get to some of the problems in this book. And I'll come back to this slide and when we get to that point. But for now, just write this down. All right, the first type of problems we're going to do is we're going to graph the function, and then we're going to compare it to that graph that I just showed you. So we have y equals 3 over x, and what we're going to do is we would just simply type in our y equals in the calculator, everything here with parentheses around it. And when you do that, you'll get a graph that looks very similar to the one that we just drew. And when it says to compare the graph to that graph we just drew, this one looks pretty close, and so we're going to just say both are similar. Because they do look similar. And then the domain and ranges are the same. Okay, they have the same asymptotes going on here, and so the domain and range would also be the same. Now number 2, if you notice, we have 0.1. If you plug this into your calculator, again, you have to make sure that there's parentheses around here. You're going to get a graph that looks very, very, very small. In fact, it's almost this small. And I had to adjust my window to even see it. So if you have trouble seeing this, I can help you when you get to the problems. But if you look at this graph, even though it's very small, it still has the same domain and range because the asymptotes are the same. So we're going to write very tiny, or you can put very small, it doesn't matter. But domain and range are still the same. Okay, now remember you're comparing your graphs to this equation that we did in the very beginning. So if you didn't copy that down, you really need to, because the book is going to ask you to compare it as well. Okay, now we're going to talk about the domain and range of graphs that aren't always 0. And so remember this slide I told you I was going to go back to, which I'm going to go back to right now. we have this general equation here. So if we don't have an h down here, of course that h would be 0. And if we don't have a k, the k would also be 0. So when we're looking at the domain and range, you're looking at the h for domain, which will be the opposite of the number that's there. And then the range is going to be all real numbers except for the k. And then k is just going to be the same number you see. So let me explain what I'm talking about. First, you would type in your calculator, parentheses around the 4 divided by x part, plus 3. And you're going to get a graph that looks like this. It's different than the graph that we originally had plotted in the very first slide. So what we're going to do here is we're going to do the domain and range, but we're going to draw in these asymptotes with a dotted line. Now remember I told you that the domain is always underneath here. You have to look at the h. And if you notice, there is no h, so the asymptote that is vertical is going to be 0 because there's no h there. Okay, so, and we're going to say domain is all real numbers except 0. Okay, now let's look at the range. Now the range, again, we're going to look at the k, which over here, you see, is 3. And so this asymptote that's through here is at 3. So all real numbers except 3. Now, if you're doing these problems, I want you to draw in the asymptotes with dotted lines. If you don't have the asymptotes drawn, then I'm going to mark you down, even on your homework. And I didn't even realize I had the domain and range down here, so go. All right, number 2. Same thing. We're going to plug this into our calculator, but before we do, I want you to pick out what the h and the k is. The h is always this number here. And remember, it's the opposite of what you see. So if it's -1, it's going to be +1. So you could already say that the domain is going to be all real numbers except 1. And I'm going to go ahead and draw that in. Remember, it goes up and down. And then you look at the range, which would be the plus k out here, which isn't there, so that means that is 0. So the other asymptote is at 0. So we're going to say all real numbers except 0. Okay, now that we've done this, we're going to plug in our y equals this function here. And what you need to do is you need to put parenthesis 6 divided by another parenthesis so that it knows you're dividing by all of that. And then end the parenthesis again. If you don't have it like that, the graph might mix up. And what you should get is something like this. Now, if you notice, if you have your asymptotes drawn in, necessarily you do not have to go through your y equals and type all that in. I could have drawn this and just made sure that it doesn't go past these blue dotted lines, and my graph would have been right. So keep that in mind. You can always double check in your y equals, but if you don't have to do that work, then why would you? Okay, now we're going to do the same exact thing. We're going to graph some functions. We're going to state the domain and range, but we have a little bit of a different setup. And this is the main equation that you need to write down in your notes. And then this set of information is definitely going to be useful. Okay, so when we're graphing the function, I'm going to try graphing this without using the calculator. So when we're talking about domain, we need to set the bottom equal to 0 and solve for domain. So here's the bottom. We're going to set that equal to 0 and solve. Okay, so the first asymptote is 3. So I'm going to go on my graph here. Remember this, the x goes up and down. So 1, 2, 3. Okay, there's the first one. Okay, now I'm going to write in the domain since we already know that. It's all real numbers except for 3. Okay, now we're going to look at the range. Now it says y equals a over c for range. So if you look at this equation, we're talking about the numbers right before the x and the y. Or the two x's, sorry. So here's a number, it's just not there. And there's a number. 1 divided by 1 is 1. So the range is going to be 1. Okay, so I'm going to draw that in and I'm going to write all real numbers except for 1. Okay, now when you're going to put your graph on here, remember that you just have to make sure it curves and it stays above these two asymptotes. Make sure it curves and it stays above, or below actually on that one. And then you're done. So I didn't even have to punch this in the calculator at all. Let's try number 2 the same way. So first we're going to look at the domain. We need to take the bottom and set it equal to 0. And now we're going to solve it. Okay, so I have an asymptote at 2. So I'm going to go ahead and draw that in. 1, 2. And then I'm going to write all real numbers except for 2. Okay, now let's look at the range. Remember, it's a over c. A is 1 and c is 4. So my range is going to be 1/4. And you're going to have to estimate that. So about 0.25 up. And you're going to write all real numbers except 1/4. Okay, now it's time to draw the graph. I'm going to draw my little curves and make sure that I stay above that and then below those.